If you clicked on this video, then I assume you already know what binary is and how to count in binary sequentially. If not, you could refer to my previous video by clicking on the card above. As these numbers are written sequentially, we can get their decimal equivalent sequentially. For any given binary number, counting sequentially up to that number is one of the way to get its decimal value. But this method is tedious and can turn out to be really hectic for large numbers. So there's a better way to convert any given binary number to decimal. To understand this method, let's first understand how the digits of a decimal number contribute to its value. Consider 4258. We know that the 4 here is 4000, which is 4 times 1000 or 10 raised to the power of 3. The 2 here is 200, which is 2 times 100 or 10 raised to 2. The 5 is 5 times 10 raised to 1 and the 8 is 8 times 10 raised to 0. We just multiply and sum them up to form 4258. Similarly, to get the decimal value of a binary number, we can use the same method. But instead of multiplying with powers of 10, here we multiply with powers of 2, which is the radix or base of binary number system. Consider 1011. The 0th digit should be multiplied by 2 raised to 0, the 1th digit by 2 raised to 1, the 2nd digit by 2 raised to 2, and the 3rd digit by 2 raised to 3. Multiply each digit with powers of 2 and sum them up to get 11. By looking up in our previous counting chart, you can easily verify that 1011 is 11 in decimal. Using this method, you can convert any given binary number to decimal. Some more examples are shown here. This method works well even for larger numbers. To do the reverse operation, that is to convert any given decimal number to binary, there is also a method. You can calculate the LCM of the decimal number with 2. Start with the decimal number you want to convert. Divide it by 2. Note the quotient and remainder. Now divide the quotient by 2. Again note the quotient and remainder. Continue in this fashion until the quotient becomes 0. In the end, you can find the binary equivalent of your decimal number by noting the remainders at each step in bottom-up fashion. Using this method, you can convert any given decimal number to binary. Some more examples are shown here. This method works well even for larger numbers. Now we know what binary is and how to convert any given decimal number to binary and vice versa. But do you know we can use similar methods to convert any number from a different base number system to decimal and vice versa? To convert a number from a different base system to decimal, you can use the same method as we did for binary. The only difference is multiply the digits with the base of the system instead of 2. Here are some examples for conversion from octal to decimal and hexadecimal to decimal. Similarly, you can convert any decimal number to other number system by performing LCM with the base of the system. You might wonder, why do we have so many different number systems? But actually, these number systems have applications in different fields, like the binary is used to store data in computers, the decimal for day-to-day interaction, octal for error detection and correction codes, hexadecimal for shorter representation of numbers. Even though there are so many number systems, then why do we use binary for computers when it would have been much easier to use decimal, as we humans are so familiar with it? Find it out in our next video.
Hey there, hope you like the video. This video is part of series called Computer in a Nutshell. If you are new to computer science, then this is the only series you'll ever need to get started. Because this series will take you on a crazy ride, starting from what is a computer, to what's inside a computer, to how each part of a computer works, leading all the way up to Introduction to Programming.
To get started on this series, you can head over to my channel and dial into Computer in a Nutshell playlist. Here, you can find all the videos from this series in chronological order. You can also find links to the videos from this series in the description of every video.
If you find this video informative, please share it forward. Subscribe to our channel for more such videos. Click here to watch the next video from this series. You can also check out our previous video from here.